All right, let's get started. Please turn to page 7 of your notes if you haven't already. We're going to start taking notes there. Now we're going to talk about units and dimensions. Units are extremely important. They're going to mess you up at some point or another in fluid mechanics. They're even a little more difficult than they were in thermodynamics here and there. But we'll go through how to do it. So first of all, dimensions. You've seen units, you know what units are. Dimensions are just the variable that you're going to put units on. So for instance, pressure would be a dimension. It's a secondary dimension. Height, weight, all those things are dimensions. Width, dimensions. But there are 4 primary dimensions that all these other dimensions can be made of. And those 4 primary dimensions are mass. And what we're going to do is put curly braces around them just to indicate that this is a dimension, this is not a unit. Okay, so mass is M, length is L, time is T, and the last primary dimension is temperature, but we already used T, so we're going to use theta for temperature. We won't be using temperature that much in this class. Okay, so as an example, pressure is a secondary dimension. It's not a primary dimension. So let's figure out what the primary dimensions are for pressure, since all secondary dimensions can be put in the form of primary dimensions. So pressure, the way to do this usually is to go ahead and use units. And also use the definitions. You know what pressure is. Pressure is force per unit area, right? So if we know that, well, the units of force in SI is newtons, and you'd say meter squared for area, right? Newtons per meter squared. All right, so those are units, first of all. They're not dimensions. We need to get dimensions, and we also need primary dimensions. So newtons, that's a force unit. That's not going to give you primary dimensions. So let's break that down. So a newton, 1 newton is 1 kilogram meter per second squared. All right, and you know that because you know F equals ma, right? So 1 newton, which is your force, is 1 mass unit, kilogram, times acceleration, which is going to be in meters per second squared. And then we have our meters squared in the denominator. So I don't like denominators within numerators or denominators within denominators like that second squared. So you just got to remember, if you're dividing, it's the same as multiplying by the reciprocal. So that is going to end up being kilograms. Now one of these meters is going to cancel, so I'm going to get rid of the meters there. Kilograms per meter second squared. All right, now you see you've got some primary units there that you can convert to dimensions. So that's going to give us kilograms is a mass, meters is a length, so length to the -1 power because it's in the denominator, and then time is the seconds, and that's to the -2 power. So that's how you can find the primary dimensions of something. We'll use that a lot in chapter 5. All right. So that's kind of the difference between units and dimensions, and we'll be doing dimensional analysis in chapter 5, like I said. So keep that in the back of your mind for when we get there. But units we're going to be using all through the class, of course. And you've already seen SI units, metric system units. Kilogram, meter, second. K is our temperature, primary unit. This is where it gets a little weird when we get to the English system. And specifically mass. Everything else is pretty straightforward. So for our English system or British gravitational system, the big thing to remember for this class is we will not be using pound mass. We are using slug. And the reason that we want to use slug is because if you think, just like we just did with that pressure calculation up above, we said that Newton is 1 kilogram meters per second squared. If you use slugs, you can do the same thing. F equals ma. All right, so 1 pound force, that's our standard force unit, is 1 slug times foot per second squared. All right, and you can use that just like a conversion. So wherever you see a pound force, you can plug in slug foot per second squared. Wherever you see a slug foot per second squared, you can plug in a pound force, and that's going to be very helpful as you go along. If you use pound mass, that's not going to work. Okay, so just don't use pound mass. So basically, if you get a pound mass, get rid of it. Convert to slugs, or they will mess you up. You shouldn't even have pound mass because your book doesn't use pound mass. So if you look up properties in the back, it's going to have it in slugs. You're going to end up with pound mass if you try to use your thermo book or if you look something up on the internet. So just avoid them if you can. If you do end up with them, remember a slug is bigger than a pound mass and it's off by a factor of g. So that means 1 slug is 32.2 pound mass. And what I had in here was the force equals mass times acceleration. So you can put that back in there. Remember that all equations must be dimensionally homogeneous, which means you can't add Pascal to a Newton per second or something like that. They all have to be the same units. A lot of secondary units, here are a few. Oh, well, we can just come up with a billion of them, but watts, PSI, erg is a unit of energy or work, mile. The list goes on. All right, one little example here. When we do the energy equation in fluids, we're going to end up with a head form of an equation, which means it's all in units of length. So the pressure head is P over rho g. Rho is density. So here we're given all these values, P, rho, and g. So let's just plug them in and get them into units of length, which in English is feet. So P over rho g is 12 psi. Now what is psi? Psi is pound force per square inch. So let's just write it that way. Pound force over inch squared. All right, and rho is 5 slug per feet cubed. Good, we're in slugs. That's always a good thing. G is 32.2 feet per second squared. You see how I wrote this again, remembering that dividing is the same as multiplying by the reciprocal, so I got all my units without any kind of denominators in the denominator kind of thing. All right, so if I look at this, I see inches squared and I see feet. One thing that I do see here that makes me really happy is I see a slug, which is mass, times a foot per second squared here. Right? All that is in the same form we need to get F equals ma, which is this up above. All right, so I can just say, okay, slug foot second squared. That's going to convert into a pound force. So let's go ahead and do that. 12 pound force times foot cubed over inches squared times 5, and I'll just go ahead and put in pound force there, times 32.2. All right. So now my pound force is going to cancel, and all I got to do is convert my inches squared to feet squared, and that's going to be a factor of 144. So if I put all my numbers out front, 12 over 5 times 32.2, what I got left here is going to be feet cubed over inches squared, and I know I've got 144 inches squared per foot squared. All right, and doing the math, I get 10.7 feet. So there you have it. So in this case, what I did was I saw I had a slug foot per second squared thrown in there, so I converted that to a pound force. The other option would be to see this pound force and convert that into a slug foot per second squared, and then cancel all those other units individually. That would be fine too. So stop here and go ahead and take quiz problems